Ask my instructor 8.6.43. Compare the errors in the midpoint and trapezoidal rule with n equals 6 subintervals when they are applied to the following integral with its exact value given. Now, in a real-life situation, you're not going to be given the exact value. If you had the exact value, you wouldn't need the trapezoidal or midpoint rule. So all we're doing here is just practicing how to use these formulas and to just basically see how they work. However, I understand that you're trying to do your homework and you're trying to get the right answer. So let me give you a strategy. Use the exact answer given in order to get an idea of what your approximation should be. And that way you'll know immediately if you're at all in the right ballpark when you go to approximate. The midpoint rule for n equals 6 would divide the interval up into 6 pieces, and for each interval it would take the width of that interval and multiply it times the height of the function at the midpoint of the interval. Our function is ln 2 plus cosine x, and we're trying to approximate it from 0 to pi with n equals 6 subintervals. I first calculate what change of x is. It's just going to be pi minus 0, so that's the length of my interval, divided by the number of subintervals, so pi divided by 6. I'm going to use that pi over 6 to find my xk's. And so my xk's are just multiples of pi over 6 because I'm starting at 0. And now I'm going to find the midpoint of each interval. So for each midpoint, I find the midpoint, and after a while you get to see the pattern and you can stop calculating and just use the pattern. So I'm now ready to use the midpoint rule. I'm going to have to rewrite this using the actual function given. So it's going to get very messy and unwieldy for a bit. Alright, so after I do this, there's really no way to simplify it. You're going to have to just bite the bullet and put this into your calculator. Be as careful as possible. Check and recheck your work. The first time I did this calculation, I had a times where I should have had a plus. And if your answer is away from that exact value, then just make sure you put everything in correctly. I've added a bunch of parentheses in order to help you get the correct answer. When I'm all done with my calculation, I round it to 8 places in order to answer my math lab, because my math lab said round it to 8 places as needed. However, don't use that rounded number to find the absolute error. To find the absolute error, use the answer that is stored in your calculator. If you know how to use a store key, that's the best way to go. If you don't know how to use the store key, then while that answer is still in your calculator, the unrounded answer is still in your calculator, just go minus pi ln, and then don't forget to use parentheses around the 2 plus radical 3. It's very important that you know how to use the order of operations, because when you switch from vertical to horizontal notation, you have to add in extra parentheses. Alright, so moving on to the trapezoidal rule. The formula for the trapezoidal rule is given here. I'm not going to take out the time to show you where it comes from. Basically, you just, instead of using rectangles, you use trapezoids, and you use the fact that a trapezoid is 1/2 times the sum of the bases, all of that times the height. And these are trapezoids that are on their sides, so the bases are the vertical lines. Again, we're going to be using the fact that change of x is pi over 6. Our xk's are the values that we're using. We're not using midpoints anymore. And so when I put my xk's into my... Oh, what just happened? Just started skipping all over the place. Where were we? All right, there. When we put our xk's into our trapezoidal rule, this is what we get. Alright, so I'm going to now use my function and I'm going to input the xk's. However, in this case, the values that we're using can work very nicely on the unit circle. So when as you put in your xk's, simplify all fractions wherever possible. And when I do that, this is what I get. So I'm looking for cosine 0, cosine pi over 6, cosine pi over 3, cosine pi over 2. These are all values I can easily find on the unit circle. And this is what I get. Now let me go ahead and back up again for a minute. If you want to use unsimplified fractions and just go ahead and calculate it like we did before, you can. The only thing I want to point out is notice that there are 7 things that you have to keep track of instead of 6. So I just wanted to point that out. Alright, so I'm not going to just input it into my calculator. First of all, it's just hard putting it into my calculator and getting the right answer. Second of all, I just like practicing my trig and my log rules. So I went to my unit circle and I found all those cosines. And now I'm just going to use the fact that ln of 1 equals 0. And then after I do that, then I start having fun with my log rules. So log of 5/2 plus log of 2 plus log of 3/2, that's just the same as the log of 5/2 times 2 times 3/2. And I'm just going to continue in this manner. You'll be surprised at how much this all gets reduced. Alright, so going from my first line down to my second line, that ln with that product 5/2, 2, and 3/2, that just turns into ln of 15 over 2. And then I have ln, 2 other ln's that I'd like to put together with multiplication. And after I multiply, you get the difference of 2 squares, so the radicals are completely eliminated. And keep going. And 4 minus 3/4 is 13/4. And then I use my power rule. 1/2 ln of 3 is ln of radical 3. And then use another log rule. Addition turns into multiplication. And it boils down to this thing that's fairly easy to punch into my calculator. And when I round to 8 places, this might actually be 9. But before I put it into my math lab, I'll make sure I've got 8 places. And then, in order to find the absolute value, the absolute error, I just do this calculation, and I'm all done. Now, this problem will take a lot of careful attention, so my big warning is just be careful. All right. Have fun, and I'll see you next time.